Okay, so what we're doing in this video is we're going to continue talking about Chapter 7, which is linear regression. Right now we're going to talk about what R-squareds are. So R-squared is actually just the correlation squared. So you find it, so you'll take the square of R, and that gives you capital R squared. There is a difference between the two, so you need to be aware of that. And what R-squared does is it measures the variance of one variable that is predicted by the other one. It provides the percent of data that is closest to the line. It provides the overall measure of how successful things are linearly related. It has variables and units, but this is the most important thing, and this is something that I want you to use this. This is like a sentence stem. So X differences explain R squared percent of the variation in Y. You have to be very careful because X does not explain Y. It explains the variation in Y, how much Y goes up and down. And so they're going to ask you to interpret R squared, and we'll practice, but you're just going to use this. This sentence will help you interpret R squared. Okay, so there's three equations you have to know. You actually have them on the formula sheet when you take the AP test, and if you're in regular stats, you always have your notes. Okay, but these are the three we're going to use. So when you have to write an equation, there's three ways you can get an equation. You can get an equation from the calculator, and we'll practice that. We haven't done much of that. That's calc, and then you do number 8, right? You also could use summary stats, which is what these are used for. And then the third way, which we haven't gotten to yet, is printouts, computer printouts. So there's three ways you have to be able to write an equation. Okay, so when you are using summary statistics, we're going to use these equations. Oops, statistics, let's spell that right. This is just y equals mx plus b. It just looks a little different. B sub 1, this one is slope. This is how you find the slope of something. You take the r, you times it by the standard deviation of y, divided by the standard deviation of x. This right here, this is the y-intercept. So when you do these, you have to do this equation first. So you do this one first, and then you do this one second, and then you do this one third. You finally plug it in here. Okay? So let's actually do some of these so you can see. So we'll keep that there. So the first thing we need to do is we need to check our conditions to make sure it's okay that we can write an equation, a regression line. So the first equation is that they're quantitative. So height and weight are quantitative. The next one is it's straight enough. Yep. Scatter is straight enough. Now, the next one is outliers. You can add it here. So, with no outliers. And the last rule, the fourth rule, was does the plot thicken? And this one does not thicken. So let's go ahead and the plot does not thicken. So because those conditions are met, we can write our equation. So I always like to go ahead and label x, y. It just makes things easier. So right here, our height is our explanatory, so that's our x. And our weight is our response, so that's our y. So the first thing I'm going to do is I'm going to use my slope equation. So I'm going to use b sub 1 equals r times sy over sx. Now you do not have to write the equation when you're solving the problems, but for notes I think it's helpful so people see where I'm getting it from. So my r value is 0.75. Times the standard deviation of y, which is 21.04, divided by the standard deviation of x, which is 2.17. Okay, so I'm going to use my calculator. Type it in. So that tells me my slope is, oh, we lost it, 7.27. Okay? So now the next one I'm going to use is the second equation. B sub 0 equals the mean of y minus B sub 1 times the mean of x. So B sub 0, my mean of y is 153.6 minus what I found for my B1, 7.27, times my mean of x, 70.96. So again, I'm going to use my calculator. So negative 362 I'm going to do 0.3. I'm not writing a lot of extra decimals because there's so many numbers in front. There's whole numbers. So now the last thing I have to do is do this. Now here's the thing. Remember, this one you have to have in context. So y is not y. Y is weight. So we're going to put weight hat is equal to B sub 0, which we found here, plus our slope, B sub 1, times our x, and our x is height. Okay, so I'm going to highlight that because that is the answer. That's what we write. Okay, so now what we're going to do is we're going to take that information and let's answer some questions. So what does the slope mean? Remember in class I gave you that sentence stem? It's right here. So the y value increases or decreases, and then how much for each additional x unit on average. So that's what we're going to do. So the y value, and the y is height, weight. So weight. Now slope is a positive number. This is our slope. So that increases 7.27 pounds for each additional, and now we're doing the x, and x was height in inches, 1 inch in height, and then that big thing at the end, on average. Okay, so that's interpreting the slope because the slope was 7.27. This number right here is going to help us for the next one, which is our y-intercept. A lot of times y-intercepts are numbers that don't make sense, but you have to be able to interpret it. Essentially what it's saying is that when the height is 0, when height is 0 inches, because when it crosses the y-axis, you don't go left or right, it's at 0. So when height is 0 inches, you weigh, or males weigh, because these are on males, right? Males weigh negative 362.3 pounds, which doesn't really make sense. It's not helpful. This thing right here, when you get an answer that doesn't really make sense, it's called an extrapolation, which we'll talk about in class more. Okay? And so it's not helpful because you can't be a negative 300 pounds. And you can't be a 0 height. You always have some kind of height. Even when you're a baby, you have height. Not helpful. Extrapolation. Okay, what is r squared? So our r value is 0.75. So to find r squared, I'll do 0.75 squared. So 0.5625. So that is 56.25%. It'll take me like 4 more minutes. And so how do you say that? This is that sentence stem up here we highlighted that's green. X differences explain R squared percent of the variation in Y. So difference in X, and X again was height. Difference in height explains 56.25% of the variation of weight. Okay, so there's a lot of little things to look for and a lot of interpretations, but those sentence stems will help you figure those out.